All right, now we're on to our third transformation, and it's called a rotation. But before we do that, I just want to review really quickly and kind of show you how a rotation is set apart from the other two transformations we've discussed. So the first transformation we discussed was a translation, and remember that is a slide. So that is a translation, a slide. Then we talked about reflection, and reflection was a flip. And this is actually going to look different when I flip it. Remember, you flip over the y-axis, or you could flip the image over the x-axis, or you could flip the image over y equals x. It would wind up down here, okay? So that is a reflection. And today we're going to talk about rotations. And rotations is actually a turn, okay? It's a turn. And if you'll notice, I'm turning this image around the origin, okay? So it's a turn. You'll notice that not only is the image moving, but its orientation is changing. Here the image is up and down. Here the image is horizontal. Here the image is back, returned up and down, horizontal, and now it's vertical again, okay? So we do need some background knowledge before we start talking about rotations. Remember, this is our coordinate plane. Here is the origin, okay? There are actually 4 quadrants to the coordinate plane. Quadrant 1, 2, 3, and 4, okay? Why is this important to know? Because you may have a question about if an image is rotated so many degrees, what quadrant would it land in? All right, so you need to make sure you know the different quadrants. We always start with 1, and we move in this direction. Now, this direction is something that's important for you to know, because if you move in this direction, what is that called? Counterclockwise. It's called counterclockwise. And the reason it's called counterclockwise is because it's the opposite direction that a clock moves, okay? So if we start in quadrant 1, we notice that labeling the quadrants moves counterclockwise. And as we're talking about rotations, the rules are counterclockwise, okay? The next thing you need to know is movement from one quadrant to another, the number of degrees, okay? So let's think about this. I just drew a circle. I started in quadrant 1, I drew a circle and came back to quadrant 1, okay? How many degrees did I travel? I hope you said 360. A circle is 360 degrees, okay? There are 4 quadrants. If I move from this quadrant to this quadrant, how many degrees did I move? Well, if you didn't say the right answer, this is how you can figure it out. 360 divided by how many quadrants? 360 degrees divided by how many quadrants do we have? 4 equals 90, okay? So a move from one quadrant to another is a 90-degree move. So if I move from quadrant 1 and I rotate 90 degrees, that means I'm moving to quadrant 2, okay? And we're going to start out today with 90 degrees, but just to help you understand, if I move here, it's 90 degrees. What if I move 90 more degrees? What's that going to be? So 90 plus 90, 180, okay? What if I move twice? 90 plus 90 equals what? 180 plus 90 more equals, well, this is not a number you probably use. 90, 180, and then 270. What if I wind up all the way back? That takes me all the way back to a 360 move. Okay? Now, not to be confused, you could start in this quadrant, quadrant 3. If you are asked to move this image 90 degrees, where is it going to go? 90 degrees counterclockwise is going to wind up here in quadrant 4. Okay? All right, so just use this as a review for what rotation means and where we're getting all these numbers from. Next, we're going to move on to the rules for rotation for 90 degrees.